Welcome back, dear students. Now we will discuss about simple shear. Simple shear force. Simple shear force. Okay, we will discuss about this. Shear means it is a rubbing action between the two surfaces. Say for example, I have one surface here, one body here, and another body is kept very near to that one. Okay, and if it slides this way and if it slides this way, and there is some rubbing action here, then this rubbing action is called as a shear. That is called as shear. Or otherwise, see, this is a ground floor, and when you walk, your leg will be like this. Your leg will be something like this, right? This is a pant and this is the shoes, and sometimes you slide it like this. No, when you slide like this, then there will be a shear induced between the this body and this body. Okay, no? This you will see. Sometimes ocean is there. In that ocean, they will glide it. They will take one boat, small glider like this, and the person who stands on this one, and after that they will glide it. No? That gliding again they are inducing shear. That one means shear means you are inducing the rubbing action between the two surface, that is called as the shear. Okay. Now the force generated or otherwise external force applied for that surface is called as a shear force. Okay. And the stress means what? Shear stress, one word will come. Shear stress word. Stress means what? Resistance offered by the body for that force. The resistance offered by the body to that force is called as the shear. For that force is called as shear stress. Okay. Again, shear force is denoted by this one SF, or otherwise sometimes Q is a denotation given for the shear force. Then shear stress is denoted by tau. Sometimes a small q is also given for the shear stress. Okay. For understanding purpose, what I can say is I will consider one fixed surface here. I will put one block here. This is the block I will put here. Then let us consider this block has some uniform thickness here. That block has some uniform thickness here, and this thickness I will consider T. This thickness is a T. Okay, this thickness. Okay, and let us consider this is a B, and this is the height is a L. Sorry, we will consider this as a L and this as a B. Okay, then this is a T, thickness T. Then the force what you apply, let us consider this shoes force only, that sliding force only, that what you apply, that we will consider it as a Q. Then when I calculate here, I will name it as A, B, C, D. Then this shear force Q is there, no? That Q is, 1 minute, this Q divided by, that stress means what? Force by area only, but this is a Q. Divided by area means this area we need to Q. Put. Why? Because this is gliding on that area, no? That area I can say that area under A, B, C, D. This area I have to consider. Okay, no? Means when I apply that force, for line diagram I can show it like when I apply this force, then this is inducing a shear, that is a surface force shear on that one. But the body is in equilibrium. The body is in equilibrium means the equal amount of stress will be developed here. This is a resistive shear force. This is resistive shear force, and this is applied shear force. Okay. Still, by this diagram, the body is not in equilibrium. You can say that if x equal to 0, why? Because this q is going this side and this q is going this side. Therefore, both are, sum will be 0. But this will cause some rotation, right? Because two equivalent forces acting at a distance apart means this body can rotate it. Okay. To stop that rotation, I need to apply one more shear this way and this way. Now see, this top Q and this bottom Q is rotating the body in this direction, and this side, this Q and this Q is rotating the body in opposite direction. Okay, now this and this two means all these four forces all together makes the body in equilibrium, makes the body in equilibrium. Therefore, if the applied stress is a q, then the resistance will be q. Then the another q is there, no, here another what I wrote here, that is called as a complementary shear, that we will call it as a q dash. But numerically q and q dash both are same, and if it is the q dash, then this is also q dash. Therefore, here we got a three that what terms for the shear. That is, one is a applied shear, and this is a resisting shear. And for these two, again to make this body in equilibrium, we will get a complementary shear. This is a complementary shear. Okay, na? Then when we apply this applied shear, and there will be developed as developing shear, and to make body in equilibrium complementary shear, these we studied. And when we apply this one, what is the effect of that body, how that body behaves, that we need to see. See, when I apply the force here, obviously this will deviate in this direction, because the bottom I have made fixed, therefore it will deviate like this. Then here I will observe some angle, change in angle, that I will call it as a phi. If this is a and this is a b, and this b is slided to this side, therefore it is a b dash. Then this angle I will measure it as tan phi. Tan phi equal to opposite by adjacent. Opposite is b dash divided by adjacent is ab. But this phi is very small. Okay, that cannot be measured in integer degrees. Therefore it is very small. Therefore tan phi is considered as a phi only. That's equal to b dash by ab. Now this is called as shear strain. This is called as shear strain. Then what is shear strain? Shear strain is a change in angle when shear force is applied for a particular side. Okay, this is all about a shear force, simple shear force. Thank you. Problems we will solve all together later. Okay, on this shear force only we'll solve many problems. Thank you.